Hi, my name is Ayushi Verma, and today I'll be talking through a couple of the homework problems for this assignment. So the first question that we have is to consider this function, finding its stationary points and then indicating the directionality of these points. So we start by taking the first derivative of this function, which comes out to be 3x squared plus 12x minus 3. We equate this to 0, and we get 0 equals 3x squared minus 12x plus minus 3. And we solve for x. And the way that I chose to do it was using the quadratic equation. And from there, I found out that x equals -2 plus minus root 5. And this is a mistake. This should actually be negative. So these 2 points, -2 plus root 5 and -2 minus root 5, are the stationary points for this function. Now we need to find the gradient, as in which direction these points are leaning towards. So we do that by finding the second derivative of the original function. So basically we end up taking the derivative of this, 3x squared minus 12x minus 3, and we find the derivative as 6x plus 12. Now what we do is we sub in x equals x1 and x2. So for the first stationary point, which is -2 plus root 5, we sub this in for x, and we obtain roughly 13.4, which is greater than 0, which indicates that it is a maximum point. And for the second stationary point, which is -2 minus root 5, we obtain -13.4, which is less than 0. Which indicates that it's a minimum. So that concludes the answer. Our 2 stationary points are -2 plus minus root 5, and they correspond respectively to a maximum and a minimum of the function. So the second question we consider is we're given the update equation for stochastic gradient descent, which is in the textbook. And we want to now write the update when we use a mini batch size of 1. So this is the stochastic gradient descent update equation. And we are given a mini batch size of 1, which means that for each step that we take, we choose one number at random from n equals 1 to n. And so that means that our update equation is theta I plus 1 equal to theta I minus gamma I times the gradient of ln of theta I, and we transpose that, where n is the random number that we chose because of the mini batch update size of 1. The third question that I will talk about is we consider convex sets and their interaction with each other. So the first part is it true or false that the intersection of any 2 convex sets is convex? I think that it is true, because the condition for a convex set that we are given is that a straight line that connects any 2 elements in the set also has to lie within the set. So because A and B are both convex sets, the points inside their intersection does lie within the set A intersection B. And so therefore, by extension, they are also convex. And if you visually think about this in terms of set Venn diagram, this shaded part in the middle is the intersection A intersection B. And so the points if you draw lines between points in this set, they will be convex because A and B are convex and the intersection is also convex. The second statement that we consider is the union of any 2 convex sets also convex? I say it is not convex, because if we were to draw some lines between A and B, in this case, of the union, it may not actually fall within the union. It could fall outside of the union, which by definition makes it not convex. And again, if you think about this visually, you've got these 2 sets, A and B, and the union is everything, so that's A, B, and their intersection, if you were to draw lines from within these, they would be inside the set. However, for instance, if you draw a line, touching outside here of B, and touching outside of A, it doesn't fall within that set A union B, and therefore this wouldn't be convex. The final statement that we consider is whether or not, if we take the difference of two convex sets, is that difference also convex? I don't think so, because so this is visually looking at the set difference. B minus A leaves us this portion of B in the set. And so you have some points which lie here in the intersection of A and B, and they wouldn't be convex because it's not part of the set B minus A. And so therefore, the set difference of two convex sets wouldn't be convex. All right, thank you.